For those of you who have been following this restoration series on a Braun Atelier 3 that I'm doing, you're probably pretty sick of seeing this. I certainly was. The radio arrived with a crack or a broken section of the faceplate on the top right hand corner and also on the left hand corner to a slightly lesser degree, but very offensive all the same. And so I've been racking my brains as to how to repair this. I tried various options. One of them was a special type of glass glue, but seeing as I couldn't find all the bits, some of them had been really crushed, you can see that the result didn't quite work out. The paint had also chipped off the back, so even if I got all the pieces together, I would have had to mix the paint exactly to cover the back end, and the chances of me being absolutely exact on that are pretty rare. So I went about looking at other alternatives to do this, and I found one, and the result is bloody impressive. So here it is. This is the new faceplate for the Braun Atelier 3. No cracks. Completely accurate dial. All the markings. No crack on the top there. Perfect logo. Look at the detail. It is pretty good. Even the small print is fairly accurate there. Once you move away, you get a real impression of what this thing looks like. And when you put the two together, this is what you got. Now, how did I go about this? Well, I did it the hard way. I took this one here and copied it, drew it, and I don't mean scanned, I mean draw, and I'll show you exactly how that was done. So the result is actually on two sections, two pieces of acrylic. The bottom piece is the one on which the printing is done. It's a 1mm piece of acrylic, so it's fairly flexible but still has a certain amount of rigidity. And the top one is a 3mm transparent, which gives it the depth and the reflection that I want, and the protection, of course. Now, I didn't do the printing myself, but I'm pretty happy with the result, and I can certainly count on these lads to do more work for me in the future, because they were brilliant. Let me tell you how I went about it. I used Adobe Illustrator, which is a vectorial program as opposed to a pixelated or pixel graphics package. So the accuracy and the exactness that you can achieve with this kind of software is pretty impressive. You can go to tenths of millimeters if you like, and everything comes out exactly as you want it. So what I did was, instead of scanning it, which is what most people recommend you do, I tried to scan it, but the scanning was abysmal. And one of the reasons is that the writing is actually on the back plate of this glass. So you're scanning through about 4mm of transparent glass. And of course, that's not going to produce a very good result. And I tried it, it didn't work. So I went and drew this from measurements of the actual original faceplate. So here we have the main size, and when you look at it, it's exact. You get it to the exact dimension that you want on the software. So then, using a reference, in this case it was the bottom left hand corner over here, I put that onto 0, 0. so everything else can be referenced to that point. I measured everything point by point in horizontal shift and vertical shift, and then redrew the object on the actual drawing of the faceplate. Now the measuring itself is actually quite tricky. So measuring across here, for example, when you put your ruler over there on the edge, you get, in this case, to this point over here, to the start of this column, of these sections here, I get 167. But if I look slightly edgeways, I'll get 166.5. If I look the other way, it'll be 167.5. So it's pretty complex to get the exact measurement on here, and you do need them to be pretty exact because you've got dials, you've got the actual dial on here. You've got positioning here that is in a certain, they're set in vectorially with the right angles and so on. So you end up having to study how each element is made on here, for example with these, and then create a guide with the right angles on there and a circle in the middle so you can get the right separation away from the center and so on. And then of course you start doing element by element and drawing it on the artboard of Adobe Illustrator. Getting all these rectangles, these clearer ones, done is exactly the same thing. You measure the distance from the left to there, and then you measure its width, and you measure its height, and you measure the height from the bottom, and you place it there, and so on and so forth. So you keep working bit by bit till you actually have the entire board or the entire plate drawn. And then you get to the little details like the positions of those markers, those meter band markers, and also the channel markers and so on top here. Now none of this is linear. You don't have exact spacing between these numbers. So what I ended up doing is literally measuring the position of each to try and get them exactly the same as it is on here. Choosing the font is also important to make sure that the lettering font that is used is the same, making sure the size of the lettering is the same. The color, in most of these cases, it's about 90 or 80% black, so it's a gray. In this case, it's a sort of orangey red. So you've got to get the color right as well. But I didn't bother too much with the color at this stage because that would also be influenced by the color profiles they use on the plotter that I was going to get this thing to be printed on. So I had to get the whole thing done and put into the artboard on there, on the Adobe Illustrator program, to scale, of course. And the result, as I've shown you, is this. So here we have the entire faceplate drawn to scale. And if you look at the detail, every single position there was measured to the best accuracy that I could achieve. And after that, I had myself a faceplate. So I thought, fine, I can take this to the graphics printer. I spoke to them. They were able to do it the way I wanted with a color plotter. They have a very big Roland plotter over there with pretty good resolution. And I then wanted them to create the other plate above, the glass panel in front really, out of acrylic as well, to give it the depth. And the total had to come to about 4.5 millimeters, which is the width of the actual faceplate. Now, I thought, fine, I've done the drawing, take it over there and let them print it and do the job. As it happens, I think they're probably a bit wiser than I am. They did a test print, and the result was quite surprising. The holes didn't match up. They just literally cut out the holes with a laser cutter. And while these over here matched perfectly with the edge, I found that these guys were about 2.5 millimeters off. They were fine with relation to each other, but they were 2.5 millimeters off. And the actual width was wrong. Now that is stupid. I mean, I don't know how I did that one, but I did. I managed to get the width wrong. So instead of going ahead with it, they called me. I went back there and they said, right, we can correct this, or you correct this. I offered to correct it myself. So I came back and did an experiment, which was to actually remeasure the whole thing, check some of the errors that I could see already on the board. Of course, they didn't print all the lettering, so I could correct the position of the holes. I guessed that some of these would be equally erroneous, so with the same shift either to the right or to the left, but I decided to recheck everything, and after rechecking everything, I decided to print it out on overhead transparency sheets, which I'm not sure you can see there, but these are these transparency sheets. I had to do it on 3 and stick them together. They're very, very faint because these sheets were actually not proper for laser printer, but once I stuck them together, I was then able to put them over the original faceplate. So by placing this sheet on top of the original faceplate, I was then able to check for errors, and I could actually see if there were any deviations. This particular drawing, or this particular printing, is probably the 3rd attempt, because the first attempt showed me there was some errors still, and I corrected those again, and then printed it out again and placed it above again. And okay, we have to shift this exactly, or you see this one's wrong, which it isn't. And then I had to reprint it and try it again. So this was an iterative process which took quite a few attempts, but I finally got it to where I wanted it. And the result was what you've seen. The color matching came next. So I took this to the lads, and they went through the catalog of colors that they have for that particular plotter. So as opposed to following my scheme, we went to the plotter resulting colors and found the best matching colors for this. We had 3 colors to choose 4 actually. The background, the color of the lettering, which I thought was black, but it isn't. It's actually, in this case, I think it's 75%, but that's on their particular printer profile. The color of this light background, which I thought was white, but it isn't. It's a sort of, God, I don't know what this thing is called, but it's not white. And then the red lettering there as well. So everything was done based on this original faceplate, and they then trusted my second drawing and went ahead and did the plotting and the cutting, and I got the result which I've shown you. What they did then is they actually cut the holes in the acrylic sticker effectively, which they printed and stuck onto the thin sheet, and also another cut which I'll show you. These holes have already been cut, and they had to do another set of cutting, which wasn't actually cutting the glass, but cutting the acrylic sheet that was painted on, or printed on. This sheet is actually white. Basically it starts as white. And there were a few parts here that are supposed to be transparent. One of them is this window for the magic eye tube. And the other transparencies are these, what you see as black lines here. They're actually transparent so that you can see the dial pointer when you're tuning. And we talked about various ways of creating this. The quality on the transparent sheet would have been inferior. So they suggested and did this, which was printed on white, and then they would cut this out with a very, very fine scalpel. And believe me, it is very, very accurate what they've done here. I can hardly see where the corners are, and it's transparent. So I still have the effect of the glass transparency, and I didn't have to use transparent sheet, so I could opt for the better quality one. And I don't see any air bubbles, which is always a problem when you stick these on anything. You stick acrylic on any panel, you run the risk of getting air bubbles, but they certainly know what they're doing. And also bear in mind that when you look at this faceplate, you'll never be looking at it with the kind of detail that we're looking at. We'll be looking at it from a certain distance, which makes the result even more indiscernible from the original. So all that's left now is to put put this back on the radio and see the result. So here's the result. Perfect fit. Man, I'm impressed. Everything in place. And no crack. Oh, that's brilliant. See how those guys fit there? Everything lines up perfectly. And you can see the dial pointer there. This one's going to get painted red, I think. And the same applies to the AM one. You can see the pointer through there. So, this thing is done. I am so pleased. Magic eye. Visible through there. Put this light out so we can see that a bit better. Magic eye actually works. And I'm happy with the geometric alignment of the knob with relation to the numbering. It's pretty exact. You can only really see it if you look at the knob straight on like we're doing now, but it is pretty exact. The names there of the channels or the buttons are in the right position, they're visible. There's one there, that RU, which was an odd one. You only see it when you press, and again that's working well. You can see that when you press it. Now, if you recall, I extended the FM range to pick up that channel over there, which is actually at 101.6 megahertz. And I was tempted to recalibrate this channel, this plate for the FM. So what I could have done is I could have redrew the markings on there to reflect the new positions, which are slightly off because I've extended the dial. But I decided to leave it in its original form. I don't want to mess with that. I think it looks better this way, and I think it's better to keep the radio original. I can always go back to that capacitor there and correct the dial scale if I don't need the 101.6. Now, as far as work on this radio is concerned, this was my main concern, the dial plate. And most, if not everything else, has been checked except for any alignment that may be required. I have yet to have a good look at that and see if it's necessary or even advisable. The FM is definitely not advisable. It sounds great, and I don't want to mess with the FM circuits because you generally do more damage than good. But I probably will be checking the IF alignment and report back. But yeah, this is the radio as it is now with its new face. Looks a lot better than the 53-year-old face of the owner, and they're the same age. No wrinkles on this one. All right, bye for now.